What's up, guys? What's going on? Hey, I'm going to go over this quiz review for you for 9-1 and 9-2. Hopefully this helps you. All right. A couple things to know going into it, guys. Know what the first difference is. The first difference is a linear function. Second difference, quadratic. Third difference, cubic. And fourth difference is, I noticed a mistake here. Let's fix that. It's going to be quartic, not quadratic. I don't know why it says that. Don't know who put that there, but that's a quartic function, all right? And the last thing I want to emphasize right here, guys, is when finding a regression equation on your calculator, if you end up with a decimal, all right, that has e to the negative exponent, all right, and that appears for any of your coefficients, a, b, c, d, whatever, you should use 0 for that coefficient, all right? Again, if you have e, all right, as the number for one of your coefficients, let me show you what I mean. All right. If we go right here to my calculator, I have some data, all right, in list 1 and list 2. If I were to press stat and go over to calculate, let's say this function, for whatever reason, is quartic, okay? And I hit enter and calculate it. We're going to end up right here with these decimals, 2.265021 e to the negative 10. Guys, we're going to go ahead and make this whole coefficient, a would be 0. So how we would write this down would be like this. We would say a x to the fourth, well, a would be 0. So we would go 0 x to the fourth. All right, see this one, negative 2.076269 e negative 7. We're going to say, well, since that's b, we're going to go b. Instead of b, we're going to put 0 because of this e. All right, so 0x cubed. All right, and then this will just be negative 0.002, and that would be 0.85. You will write those normal. There's no e down here to these, all right? But these here, with the e, man, those are 0. All right, the number is 0. All right, 0, 0. All right, put 0 in place of a, 0 in place of b because of that. All right, now let's go ahead and get to the actual review. All right, which is going to be right here. All right, take a look at this first example. All right, read it. Take a second, and I'm going to make it bigger. All righty, so a part-time student at the University of Georgia must pay an enrollment fee of $179.35 plus $2.18 per hour per credit hour. All right. Create a table and equation and sketch a rough graph that would give the total cost of enrollment as a function of credit hour. All right. So here's how we're going to look at this table, guys. Simple. We're going to go credit hour. We're going to go credit hour. On one side, then we're going to have total cost. All right. So with that being said, let's make our table. All right. Let's say if I took 1 credit, right? 1 credit is going to be, well, hold on. Let's backtrack real quick. All right. Remember, the cost is going to be $179.35. All right, plus $218.40. All right, and that would be, all right, for, you have the fee and then you have the cost per hour. All right, so you're always going to have this number times h, the hours plus the fee of $179. All right, so that actually is our equation right there. All right, so let's take a look at the table. For the first one, if I had this for 1 credit hour, I would plug 1 right here. All right, so that gives me 218.4 times 1 is 218.4. I want to add 179.35 to that to get $397.75. All right. If you had 2 hours, you will plug 2 right here. All right, so you will have $218.40 times 2. All right, plus 179.35. That's going to give you 616.15. All right, 3 hours. All right, 834.55. All right, 4 hours. Going to give you 1,052.95. All right. For the sake of this, let's go ahead and do 2 more. 5 hours. All right, you will have 1,271.35, and 6 hours. All right, you will have 1,489.75. All right, and all you're doing is taking these numbers right here and plugging them into the equation. All right, so again, that's our equation. I'm not going to rewrite that. All right, that's our equation. That's our function, or yeah, our equation right here that it told us to make. If they want to sketch a graph, guys, to sketch a graph, hey, yo, you will simply just go to your table. All right, go to your table, list 1, list 2. All right, so I'm going to go to my calculator and stats, edit. Oh, this is still here from earlier. Let's get rid of that. All right, I'm going to enter the data in my calculator. So hold on 1 second. All right, so once you put the data here, all right, you go stat, then edit. All right, I'm sorry, stat, then calculate. All right, and then let's check our function. I'm going to go linear regression right here to check it. Make sure I came up with the right equation. All right, 218.4 plus 179.35. All right, which is what we said. All right, so there's our equation. Our R squared is 1. All right, so remember, guys, if your R squared is 1, you want it to be as close to, if not 1, then that means you've chosen the right equation. All right, high percentage chance you chose the right equation right there. All right, so this is the equation we want. So next, I'm going to go to y equal. And I'm going to put my equation in. All right, so let me clear this out. And our equation is 179.35 plus 218.40. And we don't have an H here for the hour. All right, but I'm going to put X. All right, put X to indicate that. Then I'm going to hit graph. All right. Now, one thing we talked about, man, at my class, all right, and this is just for anybody else to see this video, is adjusting your window. All right, so let's talk about adjusting our window a little bit. All right, so let's go back to our table real quick. Remember our table right here? All right, my rule of thumb is I tell my kids to always choose a little bit more and a little bit less. All right, and meaning our X value, all right, this would be our X minimum. All right, this whole column represents X. 1 would be my X minimum, 6 would be my X max. So when we pick our values, we want to go a little bit less and a little bit more. A little bit less than 1, a little bit more than 6. My Y column is going to be this list 2. All right, so my Y minimum, 397.75. We always want to choose a little bit less. All right, and 1,489.8. We want to choose a little bit more. All right, choose a little bit more. And actually, for the sake of my graphing here, oh, I know what it did. All right, it rounded. It automatically rounded to 0.8. But anyway, for it's 0.75. So you want to choose a little bit more. All right, so here's what I mean for our graph. All right, if I go to window, all right, remember our X column was 1 and 1 to 6. So I'm going to choose from 0 to 6. Let's go a little bit more. All right, so I'll say 10. All right, and then for my Y minimum, I remember it's 397.75. So I'm going to go, let's say 350. All right, and then for my Y max, all right, the max was, I believe, $1,489.75, $1,489.75. All right, well, I'm going to just do a solid 1500. All right, a little bit more, a little bit less. So when I graph this thing, all right, I get a sharper image than what I had before. All right, sharper image than what I had before. All right, you can just play with it. Like, even if I wanted to make it a little further out, I wanted to see the axes, I can always make it like 0. Oh, one more. Sorry, let me clear that. But let's say I wanted to go 0, hit graph. All right. So that's my y-axis. All right. But anyway, when you graph this thing, you want to label your parts. I think that's important, man, to know how to label your parts. So I'm going to go ahead and do this for you guys just so you can see everything. Remember right here, all right, that's 0. All right. So that's our winding this up. All right. And then I can just graph from there. Just make sure you label your graph, guys. All right. So if I go to my graph, make a rough sketch of this thing. Let's see here. We'll go with this one right here. All right. We got to draw this thing. All right. It keeps going. All right. And then we need to label our parts, man. All right. So you can have right here 0, 179. All right, because if you made that 0, that'd be 179, 35. All right, this next line here could be 200. All right, 300. All right, just keep going. All right, that means it doesn't stop, but that tells us the direction it's going in. All right. Now, for this next example, option 4, we got to look at list the 4 types of representations for functions that we covered in this unit. All right, so the first one, guys, we did 3 up here. All right, so I think that's pretty simple. We made a table. All right, we also made a graph. All right, well, we got the graph from an equation. All right, and there's also, remember that quick check you did in class? I believe it was on Friday. All right, you did a verbal description. Oops. Description. T-I-O-N. All right. So add that to a verbal description, okay? All right, let's see here. Given this chart, find an equation that best fit the line. Well, you got X here and Y here. So this is going to be list 1 and this is going to be list 2. All right, so go ahead and plug this into your calculator. All right. Let's go ahead and just for the sake of reviewing, let's see if we can find a difference here. All right, 3 to 6. All right, the difference 6 minus 3 is 3. The difference here, 11 minus 6 is going to be 5. 18 minus 11 is going to be 7. 27 minus 18 is 9. 38 minus 27 is going to be 11. All right, so our first difference, we don't have the same term, so let's go one more. All right, what's the difference between 5 and 3? 2. 5 and 7, 2. 9 and 7, 2. 11 and 9 is 2. All right, the reason I did this is I just wanted to review that, all right, in case you haven't did this in a while, all right? But anyway, here's list 1, here's list 2. Because I found the second difference, when I check this equation, I found the second difference, I believe it's going to be a quadratic, all right, quadratic equation, okay? So let's go ahead and go to our calculator and go to stat, edit, and we got 1 through 6 right here. Let's go ahead and change these values out. So we have 3, 6, 11, 18, 27, and lastly 38. All right, so everything is in. All right, check, make sure your lists are correct. All right, then we're gonna go stat and calculate, and then let's check out quadratic regression right here, because we found the second difference, guys. So I'm almost 100% sure that this is a quadratic regression equation. All right, so here we go, man. We got 1 for A. All right. For B, 2.7 e to the negative 12. So remember, we just talked about this in the beginning. That means for B, I'm going to represent B as 0. All right, this is going to be 0. So what this equation should look like so far is A is 1. So 1x squared. B is going to be 0 because of that e. Make sure you look at the whole thing, guys. E is 0. So plus 0x. All right, and then C is going to be 2. All right, and then the last thing I want to find is this. Y'all see how right here, r squared is 1? That's what we want, man. All right, that's good. That means we did something right. Now, just to simplify this, 1 times x squared is x squared. 0 times x is 0. All right, so that goes away, and then 2, so plus 2. So x squared plus 2 is our equation. All right, x squared plus 2. So let's go back to the worksheet here, x squared plus 2. Is our equation, and again, we said that this was a quadratic. All right, quadratic. All right. All right. Which function best describe the graph below? Exponential, cubic, linear, or quadratic? All right. Let me move this out of the way in case you can't see. All right. Well, let's see. This parabola right here. All right. This horseshoe shaped one. All right. That's quadratic. All right. That's how you know it, guys. All right. It always goes down and up, or it will go up then back down. All right. Either one of those quadratic. This next one's a straight line. All right. Linear is always a straight line. All right. This one here, this curve right here that continues in one direction. All right. Or even if you had a curve, let me use another color, a curve that started and went down. All right. Like that red one will still be exponential. It will just be a decay. All right. Exponential. All right. And that leaves us with this last one right here. All right, which is cubic. All right. So make sure you can identify these 4 types of graphs right here. I promise you on your quiz, you're going to see something in regard to that. Okay. All right. Well, let's keep it going right here. Archer Drill team is having a bake sale. All right, the team's profit in dollars is modeled by this equation. P equals 1/2 of N, where N is the number of cakes. So if you buy a cake, your price is half of that. All right, you buy 2 cakes, your price is half of that. You buy 3 cakes, your price is half of that. All right, that just means how many cakes you bought. That's N. All right, so let's go to the next worksheet. All right, the first part says, explain what the equation means. All right, what does that mean? All right. In a nutshell, when you think about it, if you buy 1 cake, all right, you buy 1 cake, you pay half of that, right? Which is what? 50 cents. All right, you buy 2 cakes, half of that. All right, it's going to be $1 or $1. All right, does that make sense? All right, if I buy 1 cake, half of 1 would be 0.5. Or in money terms, that's 50 cents, guys. All right. So how would we explain this? All right. 2 cakes. All right. Half of 2 is what? 1. All right. So that would be $1. All right. So we got to write this as a description. All right. So one way to do that is just to explain, man. The team makes 50 cents per cake sold. All right. Disregard all that. I was just using that to explain that, guys, you can kind of think about this and get to your conclusion. All right. Now, it says make a table, all right, that will represent the profit from the cake. So here we go. We got the number of cakes. And then we have the profit. All right. So remember, if you sell one cake, all right, the equation, 1/2 of n. You sell one cake, you get half of that. Well, that's 0.5, 50 cents. You sell 2 cakes, you get half of that. Well, what's half of 2? $1. You sell 3 cakes, what's half of $3, guys? 1.5 or $1.50. All right. What's half of 4 cakes? $2. All right. What's half of 5 cakes? All right. It's going to be $2.50. All right. Or 2.5. Okay. I think that's enough. All right. If you want to go on, you could. 6 cakes, $3. Okay. All right. So jumping down here to 9, it says what type of function would best represent this data right here. All right. Well, having a look at it. All right, is it first difference, second difference, third difference? Just looking at this, guys, this looks pretty linear. All right, the difference between 6 and 7 is 1. 7 and 8 is 1. All right, 8 and 9 is 1. 9 and 10 is 1. 11 is 1. So that looks like it's linear. All right, that looks linear. All right, so again, we can plug this into our calculator. All right, stat, then edit. And you'll see right here is already 1 through 6. All right, but on this side for the Y, we got 6, 7, 8, and 9, 10, and 11. All right, so we plug that in. All right, then we go stat and calculate linear regression. We found the first difference, right? If you guys remember if you remember, the first difference is linear. All right, it's linear. So we found that. And here's our equation right here. Our R squared is 1, so we know that that worked. All right, that's a check. Now we just make our equation. We have 1x, all right, plus, and b is 5, plus 5. So we have x plus 5 as our equation, okay? X plus 5. So let's get rid of that. Go back here. All right, the equation we came up with was y equals x plus 5. All right, and we said that it is linear. All right. All right. Home stretch. Here we go. It says this table shows the cost of renting ocean kayaks for a week at Ocean Adventures. All right, use this table. Here's our table. All right, it says write a linear equation. Man, dude, you can't beat that. That tells you exactly what type of function you have. Let's go ahead and graph this in our equation. All right, but one thing I want you to do is pay attention to the years right here. All right, the years, that's how many years? 1992, 1996, that's 4 years. All right, 1996 to 2000, 4 years. 2000 to 2004, 4 years. All right, so X is going up by 4 years. All right, and then we're going to go ahead and just enter all this. This is going to be L1. This is going to be L2. So we put that in our calculator. All right, now when you get to your calculator, guys, all right, I input the data from this table. All right, but I want you to notice a difference here. All right, right here says 1992, 1996, 2000, and 2004. Those guys, those are years. Your calculator doesn't understand years, but your calculator understands the difference of years. All right, so remember right here, guys, this is 4 years. All right, 1992, 1996 is 4 years. All right, so I want to start this right here as year 0. All right, and in year 0, the cost was 28. All right, in 4 years, the cost was $42. All right, in 4 more years, which is 8 years now, guys, it was $56. All right, and in 4 more years, which is now 12 years from the start, is $70. All right, so that is why when you see my calculator, it looks a little different than what you have on the paper there, 1992, 1996, all right, and so on and so forth, okay? Now, I have my information laid out. This column doesn't change, all right? We know it's linear because the word problem told us so. All right, so I go over to calculate and I go edit. No, I'm just going to go to calculate and I go down to linear regression, option 4. All right, and it gives me the work right here, man. You got A is 3.5, B is 28, and R squared is 1. All right, R squared is 1. All right, so that means, again, all right, that check, I don't have it right here, but that check right there, this tells me I did something right. All right, so 3.5 plus 28. All right, it's going to be our equation. Now, what we're going to do with that equation is we're actually going to graph that so we can sketch our graph. So we have 3.5x plus 28. All right. Now, when you go to your calculator right here, the first thing I'm going to do is I'm going to adjust my windows. All right. And I'm going to adjust my window just because, guys, if you look, it's actually given to you on that little graph, man. All right. On that graph, you can actually see your window. All right. So Y would be from 0 to 100. X would be from 0 to 2006. All right. Again, remember, this was year 0 for us. All right. So go back 2 more years. All right. So we'll start 0 there, and or that'd actually be -2. All right. And then if that was 12, going to add 2 more to that, it'd be 14. So we're going to go from -2 to 14 years. All right. So -2 to 14 years, and again from 0 to 100. All right. So we look at our graph. Well, actually, we have to put the equation in. All right. And we said it was 3.5 x plus, oops, hold on, gotta hit the X button, 28. All right. So I hit enter, graph. All right, there's our line right there. All right, there's our line right there. So from there, remember that we got to figure out when our graph, or excuse me, the last number says predict the cost of renting a kayak in 2006. Well, remember 2006 is year 14. That's year 14. So if I go down here to year 14, I can see it. Year 14, we're at 77 kayaks. All right, 77 kayaks. So let's go back over to our paper. All right, we know that's 77 kayaks. And again, man, some of you guys may be going, why are you saying 14 years? Well, again, remember 1992 is year 0. All right, that's year 0. So 1990 to 1992 is 2 years. So go backwards 2 years, -2. So that's -2. And then that's up 2 years, right? 1992 to 1994. It's going to be 2 years. So year 2, year 4. All right, that's going to be year 6, year 8, year 10, year 12, year 14. All right. And again, these right here, these years, you really could have got from our table, all right, that we had over here. All right, because the calculator doesn't understand years. All right, so we go with that right there. All right, and then lastly, we just got to put a sketch on here, man. All right, we know that 14 was at 77 years, about right there. All right, and we also saw that 1992 was about 28 years, so about right there. 2000 had about 56. So it's 50, 56. All right, so I'm going to use that, guys, as my rough sketch here. So please excuse me while I make a line here, a little line. All right, so there's, oops, I'm a little off, but you get the idea, man. There's your line, guys, okay? Now, that's it, man. This is your review, and I wish you the best. All right, good luck.